Good morning. Uh, Today, we'll see. We have already started with C programming, and I mean programming in the sense, and then we said what is algorithm, and you know, so we discussed in a previous class regarding algorithm. Algorithm is a sequential sets of instruction, and then we design these algorithms in two forms. First is a graphical form, which is called as flowchart. Okay, flowchart. And another form is called as pseudocode. Flowchart will look like you will have a start, you will have an end, then you may have the variable declaration, and then you may have some condition statement, and based on that, you may be doing some reiterations, or you may be doing final print. Okay, start and end. And this is variable declaration, conditional statement, or many things like that. You will have a design of. However, pseudocode is set of lines. Okay, so you will say start. Okay, declare variables, and then check the condition. Check the condition, and you will specify the condition also. Check the condition whether is x less than y or something like that. Else, if satisfies, if and else you can say, if check the condition is satisfied, do something, like that. Else, do whatever you want, and then print. So you will see that it is a state of, set of uh, instructions. Okay. Now, the important thing about these flowcharts and pseudocode, they are, number one is they are independent of any programming language. They are independent of any programming language. Okay. So this essentially shows the logic. Okay. Which one is most preferable? Most preferable is the pseudocode. You will see in various advanced books, uh, pseudocode will be given. In very primary level books, flowcharts will be given. Flowcharts are very lengthy and they may not fit in one page. So you might need a breaking, symbols, and then you keep on, adding more pages, more pages. So complete picture will not be visible in a one go. Pseudocode, however, you can see, and also it is not completely completely a code, but it is a code like format. Okay, so you have if, else, do, like that, but not specific to any programming language. There is no syntax, semicolon, or proper variable name declaration, or print statement, or any scan statement, input statement, output statements. They are not there in the pseudo code. Okay, so that's the reason it is called a pseudo. Pseudo means false code. So please remember these things, pseudo code, and try to get this. You should be in a position to write a pseudo code. Also, you should be in a position to understand a pseudo code and convert this pseudo code into convert this pseudocode, convert this pseudocode into a program. Okay, so this will be your program. So you should be in a position. So any programming language. So most preferable language in many cases is a C language, because once you learn a C language, you can learn any other language. C is a middle level language. Neither it is a high level or neither it is a low level language. So neither it is a machine level or it's a very low level language. It uses both the features, and that is the reason once you learn C language, you can either go this way or that way, and you know. So when you write a computer program, what happens actually? You have a computer program. Okay. Now, computer program is written in a language in a particular syntax, and those syntax are whatever the instructions we generally give in our English language. Okay, print so and so, scan so and so, like that. But computer even doesn't understand this printf and this thing if you give it directly. Okay, so whatever the syntax, whatever the programming you have done in a particular syntax, that program first will be converted into a program which will be understood by the machine. Machine means computer. Okay, and that particular thing which converts a particular program into a program which will be understood by the machine is called as compiler. For example, in C, you have a dev C++ or dev C or dev C++ compiler, or any other compiler you have. So that compiler job is to convert whatever uh, instructions you have given, to convert those instructions into the instructions which will be readable by the computer. Okay, so basically it will be a converting into machine language. What machine can understand? Machine can understand a language of zeros and ones. Okay, so and allied maybe syntax. So then machine interprets that program and execute for you. Okay, so that's the usual procedure. So I'll just move on C programming. So when you started your C programming, so C programming is a language, right? So once we say that language, you have been taught the alphabets, then you have been taught the words, then sentences, then so alphabets, then you form a word, then you form a sentence, and then sentences forms a paragraph, and then paragraph forms a chapter or a section. Okay, and chapters and section may form a book. Okay, and different books may form volumes. Okay, like that. Okay, so the basic element of any language is alphabet. So basic rules, basic of C programming is also like that. So it starts with alphabets, and then it builds on um, a computer, I mean a paragraph or a program. Okay, so that's an analogy. So here, what in this C programming language, first thing is variables. Okay. Now we need these variables in order to suppose we want to send a data this value 10. So where we'll save this 10? So we need some sort of container, to store this value. Okay. Now these containers in a computer, okay, or space in a computer can be created through these variables. Okay, so once you say that variable ant, then computer will understand that I have to create a space for this ant variable. If you say I is a variable, then computer will create a space in a computer for this I variable, depending on its type. Okay. So there are certain rules of defining variables also. You can define this any variable having alpha numeric characters. So alpha numeric variables. Okay, alpha means alphabets and numbers. So you can have ant one like variable, but one ant is not possible. Okay, this is not allowed. It only allows alphanumeric, not numero alpha. Okay, so this is allowed, this is not. And once these rules have been followed, and these variables can be of type integer, they can be of type float. You remember, right? They can be of type real. So based on the variable, the amount of space will be, once you declare the variable, that much space will be also created in a computer memory. And that is essential. Unless we create a memory for certain this thing, where will store? So variables are very important. And then after you define a variable, we wanted to do, suppose there are two variables you have taken. So we wanted to do some operation on this variable. That is the reason we are doing this programming. We are not doing this programming just to take the input values and keep it there. We wanted to operate on these values and wanted to get some new value. So say new value is also there and we want to add them. So the addition should come here. Okay, so if you declare that add variable depending on this type. Okay, so arithmetic, the arithmetic is very important. So in arithmetic, you can have an expression like, say suppose now you say add add is equals to, say this is ant and I. So ant plus I. Okay. So this is a like an expression where you have a left hand side is equal to right hand side. Okay. So whatever operation you wanted to do, plus addition, subtraction, multiplication, that will be, those variables and those operations will be on the right hand side. And whatever value obtained in the right hand side, that will be always assigned in left hand side. Okay, remember. So this expression is always correct, but this expression ant plus I is equals to add is not a valid expression. Okay, always left hand side will be assigned in a right hand side variable, and here there is no unique variable to assign right hand side into the left hand side. So this is not a good practice. This is a good arithmetic. So understand these things, and also understand whenever you have a integer variable, the and I, if they are integer variables, integer operates, then we get a final add. This also will be an integer. You remember this? If you are integer and float, interaction between integer and float, then we get a float variable. And if you have an interaction between float means float or real variables, those who understand. When you have a float or real variables, they are interacting, you get a output that is of real or float type. These things you know, basic things, okay? And you should recall again. So you declare variables, you declare arithmetic, and what do you need? Now, majorly, you will see that there will be input output. Some input functions and output functions will be there. Because we wanted to give some input 10, 20, and we wanted to store. To store, we created a variables. But how do we ask user or anyone to give me the value of ant, give me the value of I? So to get these values or to accept these values from the user, input functions are used. In C, you remember that the function is called as scanf. Scanf. Once you write scanf, it will look for the percent, or suppose this ant and I, they are of integer, then you will have to write percentage d, percentage d. First percentage is for ant, second percentage is for I. It can be I or add. It depends on what I'm going to write next. So percentage d and ampersand, I'm writing add first. So first one is for add and I'm writing second I. So this is for second. Okay. Excuse me. So this is for this and this one is for this. Percentage D means this is for 10 and this is for the 20 number we wanted to. And you should follow a semicolon. Semicolon is a must. Okay, so you can scan this. If it is add and I, there, suppose add is a float, then you will have to have percentage F. I is a integer, percentage D. If add and I both are float, then percentage F, percentage F. If they are character, then percentage C, like that. So these things you should recall and remember. Then output, whatever the output, suppose this add, after addition, I wanted to print that add, then you will have to use a print function. So print f is a function. Brace, this is a syntax. And what value I want to print? Add, which is a float. If ant and I is a float, then this is a float. Okay, so percentage D, print add, which is add. That's it. Okay. Or if you want to print in a file, then you will have to use f print. Okay. F print f print f. Okay. This will print on the console. Okay.
So,
Ah,
I just wonder,
yes.
so could you repeat the scan F percentage D percentage D? I didn't understand that. Like, what is it adding? Like, that's find out. Could you just explain the syntax?
Percentage D. Huh?
Could you just explain the syntax?
Yeah. So percentage D is for first variable you want to insert. Say now in this case we want 10 and 20. Okay. These are two inputs. And what is the input type? Say the input type is integer. In that case, to get this input, I need two inputs. So I write percentage D since my first input is integer. Since my second input is the integer type again, so I use percentage D. And since I need only two, I finish this with double quote and then comma and then say ampersand. First is add address of this ad. Okay, so actually what it says that in the address of this ad, the value stored is 10. So once you say that this is a memory location in ad and ant, this is ant. As per our this ad and this is ant. So whatever is there in ant, uh, whatever in the sense ampersand and means it will have some address. Okay, say like 1001 and I will have some 1000, say 3. Okay, because I'm assuming that integer takes 2 bytes. So, and they are contiguously placed. Okay, memories are generally contiguously placed um, in computers. So, in the address of ant and I, what the value store the value 10, like that. Okay.
Got it, sir.
Okay. Printf will print the value on the console. So you can just see the print output and it will go. Okay, but to reproduce or to produce in a assignment or to any other your presentations, you need those output in terms of a particular file, in a particular file. Okay, text file. So in that case, you have to use fprintf format. Okay, and that fprintf you will have to first give an array of the file, and based on that, you will have to uh, print the statement in those files. Okay, so the syntax for fprintf is you have to first declare what is that. Suppose fp1 is a pointer variable for that file, and then all these things, same thing. Okay, so this fp1 need to be initially initialize like integer, float, and real or character variable. You will have to declare a printf like file. Okay, so I'll just try to you recall, or I'll try to show you one example file, and then you have to declare it by pointer fp1. Okay, it star fp1 means that fp1 is a pointer variable where you store an address. That's the meaning. To store some address. Here, whatever you are storing is a value, but I want some variable where I can store the address of some. Okay, so like 1008 or something like. I want to store the address. So you need that declaration. So file is a in a type you have to declare. So once you know declaration of variable arithmetic and input and output, that essentially defines your program. Okay, so nothing more than that will be there, but we need some specific task. We may need to store large data, or we need to work on some repetitive type of data um, in an array form or like that. So in those cases, or large data structure we need to work on. So how do we plan such a complicated uh, complicated scenarios? Okay, So in order to handle such complicated situations, you need more and more other facilities. Okay, along with this basic facilities. And in C programming, if you recall, you have various other stuffs like arrays, pointers, conditional statements. So these things are there. So plus conditional statements. Okay, these are very important. Whenever you have a logic, we say that if this is this, then do this, like that. So conditional statements like if else statement. Okay, then do while loop, or only do loop. Okay, so do, while, so and so. In do loop, you do not have condition, you just do the thing as per the instructions. Okay, so you may have loops, conditional statement, loops. Then you have the arrays. Okay, arrays can be 1D, 2D, 3D. Okay, then what facilities you have? You recall, you have pointers. Okay, pointers again, they are essentially to store addresses. Okay, everywhere we were talking about some sort of variable which is of integer, float, or real or character type, or we need some variables which need to store the address of some other variable. So pointers are essential tools for doing these operations. And by doing this, by knowing these multiple tools, you can construct your algorithm such a way that you take lesser time, lesser space, and you can do your desired activity. Okay, so pointers helps in a lot of ways, though it is very difficult to understand. And you also will know, if you noticed, if you recall and go, arrays itself is a pointer. Okay, so with this advanced features, uh, based on these arrays, pointers, things will be built up. Heavy duty building will be built up on these things only. Then you have structures. Okay, so structures essentially is like a data. This is a data structure. Essentially, what do you mean by data structure? Okay, so how my data is going to be structured? So suppose there is an NIT Calicut data. Then in NIT Calicut data, I may have one data regarding number of faculty or list of faculties. So all the data related to faculties will be there. Then I can have another structure, another data type, which will be having the data related to the employees. Okay, then data related to the students, and even in the students, I can have a data related to PhD students, MTech students, BTech students, internship students, and likewise. So in a computer program, for example, like a generalized program, then you would like to have that program itself different data types. So you can arrange those data types into a complete data structure, and you can build your program based on that data structure. Okay, so these data structures are higher advanced things which are used in all type of softwares like ANSYS Fluent, OpenFOAM, all these CFD softwares which are written and programmed. They are fully using this array, pointers, data structure, even conditional loop statements are the part and parcel, but these heavily are used. Along with that, there are other mm, facilities in um, see that you have uh, you have this linked list. Okay, linked list is a very powerful tool compared to these arrays. Okay, arrays essentially, if it is a 1D array and this is an array of 10, then it stores 10 spaces. Okay, 1, 2, 3, 4, 5, 6. Suppose this is A6. Okay, so A6 means it stores, it makes 6 locations. Okay, and contiguously. So one after another. So this will be A1, this will be A2, A3, A4, A5, and finally A6. And they will be stored contiguously in a memory location. Suppose this is 1001, then you have 1003, but then 1000, their addresses 1005, assuming that they are integer. If these are integer variables, A is an integer variable of array type, then their individual elements will be stored in a contiguous memory locations. Okay. However, in case of linked list, you do not want to store your integers of array type in a contiguous manner. Okay, so we wish to create a small space in a memory, and then it may be some for some other other you know for other this data, the other space memory location. So say this is the 1001, this may be then 8008, like, so it's a different location, different location. So in arrays, you already have to specify what size of the array. This is called size of the array. And once you specify the size of the array, you may not even use this size. You may just simply use a this two only. Okay. Now in that case, all why I'm getting this cancellation all the times. Hmm. Okay. So if you have these arrays, then you have contiguous memory location. That's the thing. And if you have linked list, then you have on the fly, you what, suppose I need a space for 3 variables, I specify for 3 variables. If I want the space for some more I mean some more data, then I assign in different memory location. Okay, like 8008, like. So what is the advantage of this and what is the disadvantage of this? As I said, if you specify I is equals to 6, but if you are using only A1 and A2, then this rest of the memory is wasted, blocked. This is a blocked memory. Okay. And many times it happens, if you work only with array and you define this array 1000 or something, then you essentially blocking your laptop or blocking your computer. And then you try to do some operation and you say that, sir, I mean, I'm not able to get the results. You will get a nan because there is no space in a memory. So computer doesn't know where to write. So it will simply give or hang, it will hang. You won't see any output. So for such a cases, linked list is a very good facility, um, which is provided by the uh, C programming. Okay, so one name is a linked list. Okay, link list, addition of the, addition, deletion, all these kind of features are there in linked list. Okay, you might not have heard about this linked list. Okay, please look into it. This is not needed also. I mean, it may not be needed in your regular program, but suppose you want to build a career in CFD code developer in good company, then you should be aware about this linked list. And then there is another facility is called as trees. Okay, so they store essentially, this is again a data structure. All these are data structures. Okay, trees is a data structure. Linked list is also a data structure. How you store the data. Okay, so in a trees you will have a data stored in a this kind of manner. It's like a tree going from parent to this thing. So pictorially it is easy, but then how to add one element of the tree to another element, that all play is related to how you store these variables and how you store the data in that sense. So these all these are to use for effective use of, for efficient usage of memory. Okay. And to enhance the speed and to improve the speed of program. So you should look into all these features. Okay, so I don't want to go into all this because all these logical statements like or, and and not. Okay, so these conditions most often is A and condition B, A or condition B and condition C less than some number. Like this you will have a condition, right? If like this you can have something like this. So if A or any of these A and B is true and this is also true, if this is true and this is also true, then you go for the condition specified here, else you go for some other condition specified. Like this you use logical operators and conditional operators like if and else, and you have these loops, for example, loops like for loop, do while loop, do while loop. Okay, so these loops have a fixed pattern. What is that pattern? If you recognize, so you will have a condition. First thing is condition. uh, okay, so not first, actually you will have to first initialize, and then you have a condition, and then you have a updation. Okay, this format is mostly you will see in all these conditional all these loops. For example, for loop you will write I is equals to 1. So what is this I is equals to 1 is the initialization of this variable I. Then you say that what is the condition on I? I should be less than equal to n. This is a condition. And then you say that I is equals to I plus 1. This is my updation. I should be incremented by I plus 1. Okay. And then you write the instructions in that loop. So initialization is the first thing. Condition is second thing. then updation. If you have a do loop, do, then you say that you do certain things and then you initialize I is equals to I plus 1, okay, while condition is satisfied, while condition, okay. Do, and here somewhere you will initialize. So you have initialize, you have updation and condition. So this format will be used in most of the do while loops. Then you have a break statement. You know, break statement is very useful. Uh, this break. Whenever you type break, the program execution will completely stop there. Okay. So these break statements are very often used when you have this menu driven programs. Okay. Like for example, you wanted a person to select, suppose there is a menu and you want people to select this item or maybe this item or maybe this item. This is called 1, 2, 3. So based on the choice, then you show the output. Based on the choice, you show the output. So these are different cases, case 1, case 2, case 3. So such a kind of menu driven programs are written using switch case statement. So switch, then you write a variable or expression. This is a syntax. So switch to this variable or expression, and then you have a cases, different case. So you have a case like case 1, okay, colon, and then you have statements. So if the case 1 is chosen, switch is a case 1, then it will go to case 1 and then perform the instructions, and you need to come out of this case 1. So you have to use a break statement. So once the compiler reads the break statement, it automatically comes out of this loop. So it completely comes out of the loop and stop working in this loop. Okay. Then again it will ask whether you want 2, 3, then you will do the 2, then you will have a case 2 or something like you will do that operation, and it will have a default case also. Default case will be there, that invalid operation or some message you need. So like you must have traveled by this trains, metros, and then you must have taken your tickets or something. So you must have pressed in this um, automatic machine. So there you have to select different cases. So all these machines are internally programmed using this switch case kind of statements. Okay. So see how powerful everywhere this kind of, C programming is. So I mean, not C programming, but any programming language is used. Okay. And everywhere it is. You have these functions. Okay. Functions are specifically a kind of um, independent block of program. Okay. Functions are specifically a programs. You can have a main program, but you can have a specific program. Okay. Specific program to do specific task. So functions are very essential. Suppose you define a function where you need to calculate um, a particular output which very often needed, for example, a root of or derivative of any function. Okay. Now this function can be used in many other programs. Whenever you need a derivative to be calculated, you will simply use this function everywhere in any other your code, code number 1, code number 2, code number 3. you know. So so that you don't have to write repetitively in your code number one the same function, code number two, okay, in code one, code two, and likewise. You need not to write the same function everywhere, but I mean, function means the code, complete code for for calculating say derivative. You need not to write. So simply you call that function and uh, get the work done. So such a kind of modularity can be incorporated using this function. That is the reason functions are most widely used. The C program itself using a function that is called as main function. Okay, main itself is a function. Okay, and there are certain library functions like sin x, cos x, mathematical functions, power. These are called as library functions. They are there defined by the compilers itself. So you need to calculate very often sine of some value or something. So they offer you these, well, I mean, predefined functions to use. Okay. Many times there is a word used for this function is called as subroutine. Tine, subroutine. Okay. So what is a subroutine? Subroutine is a sub program. This is nothing but sub program. And sub program is like a specific program. So subroutine is nothing but a function. Okay. So that function, so you don't you remember this subroutine word. Okay. This will be used, this jargon will be used very often in C community, I mean this CFD community. So you should understand whenever they say subroutine, then it means function. This subroutine word is coming from this Fortran language where they call subroutine to functions, and it is now stick to various communities. They ask about subroutines. So you have to understand subroutine means functions. So what these functions are doing, they are for specific tasks in nutshell. Okay. They are there to create modularity. Modularity, you understand? Modularity means you can use different modules. These are like modules. In my code one, I use this module which is already defined somewhere. Okay, so we can have a module. I can have another function which is defined there. I can bring it in my code one depending on the necessity. Okay, so you have modules like, you know, it's like you have bit by bit, like division of something into small I mean big task into a set of tasks, specified tasks. So that brings modularity, and then you have this subroutine. You can create subroutine for future purposes. Then you have these pointers. So as I said, pointers are you have to understand pointers as when you want to store address. Every variable which is have a space in a memory, they will have an address of that memory. And instead of storing any value in that memory location, if you want to store a pointer, then you have to use a pointer variable, and you have to specify that pointer variable for which type of data they are going to store. So they are going to store the address. Suppose I want to store a address 1002. Now this is the address of the variable I 1000 and 1002, where the value stored is 10. So that's 10 is an integer value stored in the address 1002. So what value that address variable will store, that definition you have to be here, int star j. So what I'm saying here is that this j is a pointer variable which stores the address of a variable which is of integer type. Okay. So meaning of this is j is a pointer variable. J is a pointer variable. Pointer variable means a variable which stores address. Pointer variable. Okay. Pointer variable which stores the address of a variable of integer type. Int type. Okay. If I say float here, then if I say float here or real here, then in this definition I have to say it is of float type. Okay. So it depends on how you define. So that is what the definition. Then you can store the address. You cannot store directly address in any variable. So you need a certain specific variable j. Now I can store address in this j variable. So address of I. It means that in a j variable, j variable for which a location is created, memory is created, where I am storing the address of I. Address of I is 1002, so address is stored in j variable. So see the pointer simply means like this. Then you have to use this small information in a various way. So what in which way these pointers can be used? They can be used to print somebody else's value. Say I want to print I value, but I want to use j variable. Then I can use j variable to print. I can substitute. Suppose I want to substitute I value by some other variable. So I will use some other variable like j, and I will substitute I by j. Suppose I want to change the value of I, then also these pointers can be done. Okay, so rather than working with this I variable, we are working with some other variable, and we are doing this certain objectives. Now this particular facility can be used in certain situations. Some situations will arise where our logic will say that, oh, I want something to uh, do this. Okay. So what should I do? So, okay, I can create a pointer variable and I can do like this and like that, So that logical deduction you will have to think on. And then, so these pointers essentially are devised for those kind of, um, designs. And then after pointers, so many people talks about pointer as a very difficult this thing. So spend some time on this. Spend some time on this. Uh, you work on some small things and try to understand that how what this star j means, and then you have arrays. Okay. So as I said, whenever you define an array, AI, so A itself, the meaning of this itself is a star A plus I. Okay. So A plus I is a variable, pointer variable, which stores the address of, uh, a variable of, the type int or whatever you write here. Okay. This also means that star I plus a. Okay. These are commutative. You can interchange a and I. So this essentially also means I of a. Okay. So these are interchangeable. And this facility is coming, so pointers are inherently used in arrays, and by definition they are like this, and you can have a meaning of this type of arrays and combination of arrays and pointer. So I just wanted to show arrays and pointer combination to understand what AI means. You can use these things, and you can go ahead with you can use arrays with functions, right? Arrays and functions can be used together, and you can do the work. Okay. Structures, uh, structures, these are collections of elements of dissimilar data type. Okay. Collection of dissimilar data type. Arrays are collection of similar data type. Similar data type. Similar data type means either it will be integer, either it will be float, either it will be character or like that. However, structures can be a collection of integer, float, character, like this. So collection of dissimilar data type. Collection of dissimilar data type. Okay. So now suppose we say only I'll work with array. So only it is useful for similar data type. But suppose I do not want similar data type, I may come across with some situation, I need dissimilar data type, and that is a general case. In all this C fluent code or any other code written for large CFD application may have this data structure, may have these dissimilar data types. Okay. So collection of dissimilar data type can be done in a structure, and you have you have to recall the how you do the syntax. So you have to define a struct, name of the structure, then you have to define data type inside, and then semicolon, then struct, name of the structure and number of variables, or define with respect to that data structure. Okay. You can combine then arrays with structure, okay, or structure with functions, structure with pointers, and things like that.
Sir,
Yeah,
sorry to interrupt, sir.
yeah,
We
it's
have this
time.
max
Time over.
class. Yes, sir. We have max class from 11:15
Oh
to
yeah,
12:15.
I'll stop. I stop here. Huh? Thank you.